All right, everyone, good evening and welcome back to another session for Blockchain Developer Week, day number 4. Wow, we're already in day 4 of this week. For those who are just tuning in for the first time, welcome to Blockchain Developer Week, brought to you by Access Blockchain Association of Malaysia, along with its many media partners, including Bitcoin Malaysia, Blocklime, TalkChain, ETH Grenade, App Media, DeFi Singapore, and Imperium Universe. What is this Blockchain Developer Week about? It is actually part of a larger series of events called Malaysia Blockchain Month. How it works is 6 weeks of events. Okay, every single week is a different theme, and now we are on the week number 5, day 4, Blockchain Developer Week, and we're ending Malaysia Blockchain Month with a 2-day conference called Ignite next week. Wow, 6 weeks of events. Why are we doing this? Because as an association, our mission is to grow the industry. What kind of industry are we talking about? An industry where digital assets live on the internet. And these digital assets are secured by decentralized networks called blockchains. This year, very interestingly, this industry had hit the milestone of $1 trillion in January, which is if you add up all these digital assets. And guess what? It took 12 years for us to get to this milestone, but it only took 9 months for this industry to double in growth. That is how quick this industry is growing. So this is why we are having this Blockchain Developer Week, to grow the talent, okay, and to help you to speed up your journey in actually building a career and building the next Web3, okay, on this uh, industry. So that is why, okay, this week we have a lot of sessions, okay, to help give you a very big overview and as many options as possible. We had a lot of special guests in the past. Tonight, we have another special guest all the way from the US. His name is Mario Christopher. He's a solutions architect at Consensys Quorum. Mario, thank you so much for joining us at Blockchain Developer Week. Mario, you're muted.
Thank you, Jason. It's my pleasure to be here.
So we're really excited, okay, to get started. Why not you begin by introducing yourself before you go into the bootcamp?
Sure, I'll do that, Jason. Thank you. Um, Good evening to all my viewers there, and good morning, good afternoon to viewers chiming in from other parts of the world. Thank you so much for joining us this evening for this developer workshop on getting started with Consensys Quorum. So, for those of you who were here with us last week, we did present a brief introduction to the product, and this week for this session, we'll be going live deep into the product where we'll be giving a live demo on how we get started with Consensys Quorum as the product. In this demo, we will create our own network, a private network. We will create some private transactions in this. And as Jason was saying for my introduction, I'll be having a slide here just showing my introduction for that. So it's going to be an exciting evening, so I'm hoping all of you are excited and staying tuned for this. The agenda for today's evening would be a brief introduction to Consensys, the company, followed by an introduction to Consensys Quorum, the product, and then we'll get into the main focus of the session, which is the demo or the walkthrough. Finally, we'll conclude with some Q&A. But before I get deeper into the presentation, please allow me to introduce myself. My name is Mario Christopher, and as Jason said, I'm a solutions architect at Consensys. I'm making this presentation today this morning from Denver, Colorado in the United States, and it is 6:05 a.m., so I am up bright and early for my viewers out there. So, what I do at Consensys as a solutions architect is to bridge the gap between business problems and blockchain technology. So, in other words, what I do is I listen and understand the business problems that our customers bring, and I use the products from our company along with the vast experience that we have in the blockchain area to come up with a technical solution for them, thus bridging the gap between their problems and a technology solution. So today I'll be talking about one of those products which I just mentioned, which is Consensys Quorum. So with that introduction to myself, I'll be moving further into the presentation. So Consensys. As I said, I'm a solutions architect at Consensys. And who or what is Consensys? Consensys is a leading Ethereum software company. And as a company, we enable developers to build the next generation application. We enable enterprises to launch modern financial and trade infrastructure. And we enable people worldwide to access the decentralized web. At the bottom of the screen, you see our product suite. Each one is a leader in its own space in the blockchain arena. So, who are the people working with us? This slide shows a brief of a number of Fortune 500 companies who are partnering with Consensys, working and coming up with blockchain solutions that's revolutionizing the digital world, helping us realize Web 3.0. So you see a number of key players in there, large companies, Microsoft, JP Morgan, Fidelity, Coinbase, etc. So all these are partners that are working very close with us and coming up with various digital solutions, helping people out there in their digital world. So with that, let's move on to Consensys Quorum, the product, the main focus of today's presentation. Consensys Quorum is the world's leading Ethereum protocol layer for enterprise applications. And when I say enterprise applications, this is an enterprise Ethereum network, which is private, which is permissioned. So say, for example, 3 or 4 banks want to come up with some kind of a solution for themselves. They do not want to use a public mainnet. So the best solution then for them would be to go for Consensys Quorum. So this is a enterprise Ethereum solution which allows them to create their own permissioned network with privacy features, highly scalable, unparalleled security. As a product, Consensys Quorum is an umbrella, and under it you have two flavors. One is the Hyperledger Besu, and the other one is Go Quorum. So Hyperledger Besu is written in Java, and it can be used to communicate both with the main network as well as with the private network. Whereas Go Quorum, written in Golang, is used mainly to communicate with a private network, to create that private network. Here I'm showing a brief slide on the progress of the software to show where we are today and how we reached today. So Consensys was founded 2014, 2015, and at that time we started our protocol engineering group and systems, also known as Pegasus. So this was a group that came up with the new product called Pantheon. Pantheon was the initial version of our Hyperledger Besu, of our Ethereum client. Over the next couple of years, we improved and we optimized Pantheon and finally submitted a version to the Hyperledger Foundation. As you all may be aware, Hyperledger Foundation is an group which is collaborating for the use of blockchain solutions for optimizing blockchain solutions. So Pantheon was accepted and is now part of the Hyperledger Foundation. And at that point, we also rebranded the product from Pantheon to Hyperledger Besu. At about the same time, a couple of years ago, JP Morgan, which is a leading bank in the US, also were working on a similar product, which was for a private network. So they forked the Get Ethereum client and they extended it so that it can be used to create private networks and form these consortiums between banks for blockchain solutions. A couple of years down the line, we at Consensys acquired the product from JP Morgan. It was at that time called Go Quorum, and we bundled it together with Hyperledger Besu under this bigger umbrella called Consensys Quorum. So that's how we are here today with our product called Consensys Quorum, having two flavors, the Hyperledger Besu, which was developed at Consensys, previously known as Pantheon, and Go Quorum. So the product Go Quorum, this slide shows us the tech stack of the product. So we have at the top the ETH Signer, which is an open source product, which is used to sign the transactions in this private network. We also have another open source product called Tessera. Tessera is used for private transaction management, and this is a product which encrypts and decrypts the payload of each transaction. And when we see the demo later on, we will notice that a Tessera node is created for every corresponding node or member in the private network. The reason we have the separation is basically separation of concerns. We want to have our encryption, decryption process happening somewhere else rather than on the main node, thus reducing the load on the node. So it's more of a separation of concerns. So every member or node on the private network will have a corresponding transaction manager node called Tessera. We also have a configuration where we can have multi-tenancy, where multiple nodes or members can share the same Tessera node for encryption, decryption of private transactions. But we'll look at that a little more in detail later on. And then below that, both the clients are there, the Hyperledger Besu and the Go Quorum client. The product is also available under various support licenses. As you can see on the screen, we have bronze, silver, and gold. You can visit our website at consensys.net to figure out more about this and learn how these support plans can actually help you as an organization. So who's using Consensys Quorum and where is it being used? This slide shows a brief category like the financial services, the supply chain, and various other use cases. And under each of these, you can see a lot of key players in the area out there. All of these players are working with Consensys, coming up with their private networks, permission networks. If they use Hyperledger Besu, then they can connect to the mainnet, so it is highly compatible with mainnet. So there are various use cases under which Consensys Quorum is being used today by all of these main companies. This was a post recently on my LinkedIn. So we can see that Azure used to have a service called Azure Blockchain Service. It's now deprecated. And instead, the people who are using Azure Blockchain Services are being redirected to start using Quorum blockchain service. So Consensys has this blockchain service available now on Azure as a managed service. So it is a blockchain as a service product from Consensys. It is compatible with Azure Blockchain Services API. So it's a very easy way for people migrating from ABS into QBS. So just a point to note that how Consensys Quorum is now gaining popularity and it is available as a major service on a major cloud provider. Okay, we're done with the introductions. Let's move on to the main focus of today's session, which is the demo and the walkthrough. For this demo, I'll be following along this starter page. As you can see, there's a URL on there. And if I hit that link, I'll be taken to this product page. So this is a page which is a quick starter guide. It gives us a step-by-step instruction on how to proceed with this. What this guide is going to walk us through is first, allow us to do our installations of necessary dependencies. We then go ahead and download and install the actual product. So this brings down all the code down in a prepackaged format. It makes it easier as a quick start developer to look at how the code is and what's to be done and some samples in there. We then have a setup of MetaMask wallet, which is one of the leading products from Consensys. It is a mobile wallet as well as a Chrome extension for us to interact with the blockchain. We then set up and run the private network. We use some monitoring tools and then we deploy a smart contract. I mean, what's the point of having a blockchain network without smart contracts? So there you go. This is a guide that we'll be walking through. It's going to be quick and exciting. So jumping back to the presentation, right? Before we get started with this, there are some basic requirements which need to be installed. For example, Docker Engine, Docker Compose, Node.js, and MetaMask. And for this, although this product runs on Mac, Linux, and OS, I will be walking us through a process on the Windows laptop. It's a little different, a couple of extra steps for the Windows laptop, but we shall look at that. So here it is. So for Windows, we first have to make sure that we enable Windows subsystem for Linux, WSL2. We then go ahead and install Docker for desktop, install a Linux distro. I've chosen Ubuntu, but you are free to choose whatever your favorite distro is. And in that distro, I install Node, I install Docker Engine Compose, and finally, I set up MetaMask and VS Code. Now, VS Code is optional, and I just use it because it's a good one-place stop to show code, to show scripts, etc. Now, for the sake of time, I've gone ahead and done all the steps 1 through 6. So we'll just see number 7 and proceed further. In that way, we get right down to it. So switching now to my code window so that we can look at the actual stuff. So VS Code, many of you are familiar with it, and I hope the font is big enough to see. Right, so with VS Code, the way I connect to my distro is by having an extension, and the extension that I have installed is Remote WSL from Microsoft. It helps us connect to the remote distro, which is Ubuntu Linux on my machine. So I click on this link, and I have the Ubuntu uh, distro there. So from there, I connect to it. It opens up another VS Code window. I close the previous one, and this is my window now. And as you can see, I am now in Linux. And this is my home directory. I have an empty folder there, Quorum, which I created for today's presentation. And the way I open up the folder there is open folder. It brings up this, and I select Quorum. Okay. Okay, so now we are in our work folder where we want to do our stuff. As per the guide which I showed you earlier, the quickest way to get started with Hyperledger with Consensys Quorum is npx quorum dev quick. So what this command does is it pulls all the necessary files down to my local machine and puts it in a state that we are ready now to start our network. Oh, quorum dev start quick dev start. So let's just pick it from there. Okay, so here it is. Right. NPX. That was a typo from my side. Okay, so while this is happening, it's a quick process. It gets some packages and then walks us through a small a guide here to specify how we want to initially configure our system. So it shows us here a Quorum developer quick start, and it asks us a few questions. Again, all of this is clearly listed down in the guide page, so you can follow it from there. But the first question it asks us is, what do you want to run this as? As I spoke earlier, Consensys Quorum comes under two flavors, Hyperledger Bezu and Go Quorum. For this presentation, we will be going with the Hyperledger version. So I select one and hit enter. It then says, do you want to try out Codify Orchestra? It is another product from Consensys, but we won't be looking into this. So I'll just say no. Do you wish to enable support for private transactions? Yes, we want to show how private transactions work in this presentation, so I'm choosing yes. And finally, it asks me, this product provides a lot of support for logging. We're using Splunk and ELK, but for now, I'll just choose none because I won't be going into monitoring too much for this presentation, so I'll choose none. It's now ready to download all the files, and it asks us which folder do you want to create. This is the default folder that it creates it under. I'll just choose Bezu. It's a smaller name for me to type instead of that whole big name. So I go with the folder Bezu. Once I do that, it completes the installation. And as you can see, there is a Bezu folder right now in my code. And when I open it up, it shows all the code that it has just downloaded. A brief look at these folder structures here. So the Block Explorer, it allows us to look into the blockchain, and we see a small block, a simple screen, which allows us to browse through and explore the blocks. The other folders here are Elasticsearch, FileBeat, Logstash, MetricBeat. These are support folders for the logging mechanism. And then we have these two main folders, smart contracts and dapps. So I'll go into smart contracts at a later point in this presentation, and dapps again will be towards the end of the presentation. What these basically are is it's going to be a set of contracts that we would be deploying onto our private network. And the DApp is actually a test application, a decentralized application, having a front end, a back end connecting to our private network. So this again will be deployed. If we have time, we'll definitely look into that. At the bottom, you see some scripts which help us go along. The main one is run.sh. As you can see here, it says to start your network, run.sh in the folder. So let me go into the Bezu folder. I'll clear out my screen for now. Okay, so if we look at the run.sh, let me start the run.sh and then talk about it because it takes a minute or so to run. So run.sh, and I execute the script and it goes ahead and does its work. So what it's actually doing now, if we look at the script here, it's doing something simple as running Docker Compose and starting it up. So it looks at the local Docker file and starts creating all these containers, downloading the images and working on these containers. So as many of us know, Docker Compose is a file which helps us create a whole environment, a whole structure, a whole network. So it creates a container for each of the different nodes that we want in here. So what is the final picture going to look once this network is up and running? We'll switch over to the presentation and look at that. Here you go. So this is going to be the architecture of this quick start, which is now being installed on my local machine. As you can see, it's having quite a few pieces here or quite a few nodes, but I'll just go over the main ones. Um, as an imaginary example, let's assume three banks are coming together to do this and they are creating a private network using Consensys Quorum. These three banks are represented by node 1, node 2, and node 3. So that is out there. And I also spoke about Tessera being our private transaction manager, and each member node would have a corresponding Tessera node, and that's what we see, the three transaction managers alongside each of the node. And all of that is in this little bubble here, the yellow bubble for the privacy. If you remember, we did select the option for private transactions on this network. So now we have Tessera managing the private transactions. And finally, we have the main players on this network, which are the validators. Our network here uses proof of authority consensus mechanism, and in a proof of authority mechanism, we call the miners as validators. So the validators are responsible for creating the next block. Now, the reason we have validators is because each block that is created has to be validated by somebody, and in our proof of authority network, the validators play that role. We need to have 66% consensus from these four validators in order for a block to be validated and added to the blockchain. Validators can be added and removed also. And for that, we need 50% consensus on these validators. So if two validators agree, then a new one can be added. If two validators disagree, then if more than two validators disagree, then a new validator will not be added. So we see here that there are three nodes, there are three transaction managers, and there are four validators. So in essence, we have seven peers, the three members and the four validators. Let's go back to our code window and we now see, yes, the process is completed, and let's have a quick look at what's being done. So these are the containers that have been created. And as I was talking about, here are our validators, validator 1, 2, 3, 4, member, and the member tessera. Good. So our network is up and running. How do we know our network is up and running? We see the list of endpoints that is available here, so we can browse to these endpoints and see them. At any point in time, you can always check what are the services available by the list.sh script, which again is right here on the left-hand side. So when we open up that, it again brings up a list of services that are currently available. Good. So Let's jump quickly into the Block Explorer and see our new blockchain that has been created. So here is the link for the Block Explorer. I control click on it. Right. So here is the block explorer that comes up. And as I said, it's a minimalistic block explorer where you see that this is the Hyperledger Bezu flavor of the Go quorum. It's got 7 peers, like I mentioned, the 3 members and the 4 validators. It's got the current block is block number 54. It has no transactions. So if I quickly jump onto block 54, here you see the contents of that block. There are no transactions on it. Now, I would like to jump quickly over to show how this network was created and what kind of settings it was created with. So going back to the code window, if I go to the config folder, Bezu, and inside here, I have the Genesis file. So we use the IBFT protocol for our consensus. So now the Genesis file is used to create the Genesis block on the network. It also provides some important information about how this network is going to function. As you can see, it's got a private, a unique chain ID. It specifies how often a block should be created. In this case, we are creating blocks every 2 seconds. It provides us with the nonce, the difficulty, etc. A Genesis file is also a great place for us to pre-populate with some accounts. So for our purposes, I have these 3 accounts created in here with some predefined balances. For many people working with test networks, you'll know the importance of having pre-populated accounts and balances. It helps us get a quick jump start in having accounts and in dealing with Ether, etc. Now, a word of caution, in the real world, private keys should not be stored here. Please follow best practices for managing keys in a key vault, etc. But for our demo purposes, we have the private keys here and we have some initial Ether given to them. So with that said, let us see how we can make some transactions. So what do we have so far? We have our private blockchain network running 3 members on it. We now need to interact with that. The most basic way you can interact with a blockchain network is through a wallet. For our purposes, we are going to use MetaMask as our wallet. Let's go ahead and get that set up. So I have the link here, MetaMask, and it takes us to the MetaMask homepage. MetaMask can also be installed as a Chrome extension, so that's what we'll do for this presentation. I'll go ahead and install MetaMask for Chrome. It takes us to the Chrome store, and I click on the Add to Chrome button, Add extension, and it's doing this little thing here, checking and stuff and installing. MetaMask today is one of the leading wallets for accessing the Ethereum network, and the ease of use is it's now available as an extension on the browser. Okay, so it's set up. So I come to my extensions and I click on pin so that MetaMask is always available, and I configure MetaMask. I'm going to create a new wallet and I'll breeze through the steps. You can always visit the website to figure out more about what MetaWallet is. Help us improve. I agree. And I'm going to create a password, PASSWORD1. SSWORD1. Obviously, this is the best password in the world, but I encourage you to create a unique password which cannot be broken. For the demo, my password is password1. Create. It has now a small video, which we won't check. I'll go to next. It allows us to back up a secret phrase. You can visit the website to figure out what a secret phrase is. I'll say, remind me later. Okay, and there we are. MetaMask is set up. Now, as an extension, how does that work? So let me close, perhaps, right? Okay. So when I open up MetaMask, as an extension, we do see that there's a drop down at the top here. At present, it's connected to the Ethernet main network, the public network, but we want this to connect to our own private network. How do we do that? If I go back to my page here and I check this out. So here you see one of the endpoints is the actual JSON RPC HTTP endpoint. This is the endpoint that the wallet should be talking to, that your decentralized app should be talking to in order to connect to the private network. So on the extension, I now pick the local host network. You see all the other networks, these are test networks for the Ethereum blockchain, but we'll be going for the local network here. And when I select that, I am now connected to my local network. How do we know that I'm connected to my local network? Let's perform some transactions with our wallet and see that we're now working on our private network. If I select accounts, there is a default account created by MetaMask, which has got 0 Ether. But for those of you remembering this, I did say that we have 3 default accounts created. So let's pull these 3 accounts into MetaMask. The easiest way to do it is to take this private key and import it into MetaMask. For any private key to be a valid Ethereum address, it has to be prefixed with 0x. So I go into MetaMask, I import account, and I say it's going to be a private key type, and I put 0x and paste the key and import it. And there you see we have 200 Ether that's created. And just to make it easy for us, I'll edit this account's name and I'll call it member1. So this is going to be representing member one's wallet. Quickly, I do the same for the other 2 accounts so that we would have 3 accounts in our wallet and we should be able to do some interesting transactions. So my second key is pasted there and I edit the name to member2. As you can see, this is preloaded with 90,000 Ether. Yay, boy, I'm a rich person. So I get this third account and import that one too. Import 0x, paste it, and I rename this to member3. So now we've set up our wallet and we have these 3 accounts in here. So let's do a simple transaction. But before that, let's search for these members or these accounts on the blockchain. I copy this address, I paste it in my blockchain explorer. And you see that it's brought up the information. It's got 200 Ether. Great. So we know that this account is on the blockchain. Let's do transaction. So I send some money or Ether transfer between my accounts, and I'm sending it from member1 to member2. Select member2 and I send 23 Ether. As you notice here, there is 0 gas price. It's a private network, so you don't necessarily have to provide gas. So I click on next, confirm this transaction, and it is now in pending state. Okay, this pop-up is here, so let me remove this pop-up. Go to settings, advanced, and there's an option at the bottom. I just take that off. Great. So, okay, so this is a notification which says that it has confirmed the transaction, but I'm sharing my screen, so I guess it's privacy concerns, it's not showing that. Anyway, so the transaction is done. And now if I refresh this page, oh, here's my transaction confirmed. If I refresh my page, it shows 177 Ether. So great, my transaction has worked. And further, if I select this transaction, it shows me the details. I can copy the transaction ID and go back to my blockchain explorer, paste the transaction ID in here, enter, and it should now bring up the transaction. So what we've been seeing here so far is that transactions are now possible on our private network between the accounts that I just imported in here. So that said, it's just running a little bit slow. Okay. So with that said, now we jump back to the code window to move further in our presentation. Something is happening as usual. Okay, in a demo, it's always nervous in a demo. So I clear my screen. Yep, something is definitely happening. You can see that VS Code right here is struggling a little bit with probably something else is running on my machine. I need to clear up stuff here. Anyways, so while that is happening, okay, we now see that the transaction which I selected earlier now shows up, and it's clear that the transaction was from this address to this address. That's member 1 to member 3 and member 2, and here is the 23 ether that was transferred. We also see that it's written on block 184. So if I select that block 184, it takes me to that block information. It was mined 3 minutes ago, and we see the transaction details here. We also notice that the blocks keep creating here. As I mentioned, the Genesis file is going to be a 2-second interval between blocks. So blocks keep getting created as and when we look at stuff. So going back to our code window, it's still having a problem connecting to my distro. Let's see. Come on. Okay, so we shall now look at running transactions. How do we do that? So I'll now switch over to the smart contracts folder, which I spoke about earlier, and look at its content. So this smart contracts folder is going to be having the contract that we want to deploy onto our local network, onto our private network. The moment that it, for some reason, is having problems connecting to the Ubuntu distro, so I'll just wait for that. Okay, so while that's happening, the private network that we have created is now just 3 members, and it's going to do nothing until we put some code in there in terms of smart contracts. So smart contracts is the way, okay, so that's the thing. Yeah, smart contracts is the way we move our code into Ethereum blockchain, and smart contracts is the way we enclose or put in our business logic. So we have a simple contract here, simple storage. And for those of us familiar with smart contracts on Ethereum, smart contracts are written in Solidity language. Solidity language is very similar to how, in terms of syntax, it's very similar to how JavaScript or C++ is written. So here we see a very simple smart contract. It's called simple storage. It's just got a local variable here. And while that's happening, what I could just do is so that, right. So what this, yeah, I'm having a problem connecting to my Ubuntu distro. So it always happens, right, in a demo. So open an integrated terminal. Right. So while that is happening, I shall just explain a little bit about this smart contract. So this smart contract has got a local variable called smart store data, and as having a constructor which allows us to pass in some default value for the smart contract's state. We then have 2 methods, get and set. So set, you pass in a value and it's able to store it to the local contract, to the local variable, and you have a get, which then allows us to retrieve the value back from there. So the part of this exercise is to deploy this contract onto our local network, and from there we should be able to interact with it by sending transactions, by updating values. Oops, yep. So let's reload the window and hope it works fine. Everything happening. So while this is happening, what are you all doing right now? Having dinner, having fun, watching a movie, or watching this presentation? I hope you all are watching this presentation.
I think
And while
we
that's
are.
loading, we can quickly look at the actual page here, the quick start guide. So just in case that fails me, I will at least be able to walk through this quick start guide and show where we are in this process. So we've installed the dependencies. Yes. We have installed Consensys quick start. Yes, we've done that. We've installed MetaMask. Yes, we've done that. We've also in MetaMask, as I was working on through that demo, I copied the keys and I imported the keys. So you see all the steps that I just performed is available on this web page. What I was trying to do next was to look at the smart contract and deploy the smart contract. So we have the code also displayed here, which is the smart contract code that's going to be deployed, and it has some steps on how to run this. So let me just check here. Okay. Um, Still looks like we're having some technical difficulties in this place, but no problem. As I was saying, that the guide is a complete step by step on what's to be done. So we'll just give this another few seconds, and if this doesn't work, I'll continue with the web page to show what we are doing.
So we have a question.
Yes.
Okay, so one question is, what happens if someone accidentally keys in the gas amount on MetaMask in Bezu? Where does the gas go?
The system, um, that's a very good question. The system takes that gas amount, but it doesn't use it. So towards the end of this presentation, I'll be providing you with a slide which shows contact, how to get into Discord channel to get information from us. So questions can also be redirected to chat.consensys.net, which will then come back to us Discord channel, and we'll be able to handle questions in a better way. But as of now, the answer is the gas is not used by the system. It doesn't. It comes back to the user.
Cool. Thank you.
Yeah. So
So are the
going.
demo gods favoring you right now?
Doesn't look like it. So I shall walk through the actual web page, which is actually step by step of what I was doing. So no harm. We still have the benefits of what this deep dive is supposed to do. So for the deep dive, I was supposed to deploy the smart contract, but the demo gods are saying not now. You shall not pass. And here's a smart contract. A step-by-step information is here on how to deploy the smart contract. The next exercise which I was going to work with was to deploy a DApp. Many of us are familiar with a DApp being a decentralized application, which in some cases is a full stack app, which then has a connection to the blockchain. The full stack app would have a front end, would have a back end, would have an arm reaching into the blockchain. In our case, we have a dApp called a pet shop. So a pet shop is a little nice looking demo, which, as the name suggests, is a pet shop. It allows you to deploy a pet store. It then deploys a contract called adoption.solidity. So as you can see in this page here, there is an adoption.solidity file. If this comes up, but it's still not up, right? So this adoption solidity is a very simple contract. The code is right here, and we we would be deploying this contract. Okay, here it is. Right. Right, here's the Solidity contract. It's just got, again, a simple local variable and two methods in it, adopt and get adopters. So once the smart contract is deployed to the blockchain from the front end, we should be able to adopt a pet, see who are the people who are currently adopting the pet, and thus make our transactions with the private network. How does this web page look like? So if you scroll down, it just talks to you on what happens when you run the script to install the pet shop, just like how the private network was done. the pet shop run script is going to download all the files necessary for the pet shop project. It does it using something called a truffle box. So truffle is another product from Consensys which allows us to develop smart contracts, compile them, deploy them to the blockchain, allows us to write unit tests for the smart contract. There is a whole framework for developing and testing your smart contracts before it goes to production. So I would encourage all of you to download Truffle and try it out sometime. But for this demo here, we would have been using a Truffle box. So a truffle box is something like a compact solution containing all my files. You can consider it like an npm package or like a Helm chart, something like that, which combines everything that's necessary to write my application and download it as one box, expand it in my local machine, install all the dependencies, and get things ready for running. So in this case, a truffle box would have been for a pet shop application. And as I was saying, it's going to have its own front end, a back end, and talking to our blockchain, which will be the smart contract on our blockchain. The front end here is designed using React. So when you actually go through this process and you run the application, you will now see this page with cute little dogs on the page. Clicking on these adopt buttons would now allow you to interact with the smart chain, with the smart contract on the blockchain. So the smart contract that was deployed was adoption.sol. When you click on the adopt button, the MetaMask notification would come up. So here's a MetaMask notification saying this transaction is going from the pet shop, the current logged in member, to the smart contract. This is the address of the smart contract. We then proceed with the transaction, and if it completes successfully, you would have adopted that pet. So you'll have to take good care of that pet because now it's your responsibility. But otherwise, that app would show a clear picture on how you deploy a full decentralized application with the front end, with the back end, with how it interacts with the smart contract, how it interacts with the MetaMask wallet, and gets everything running. So that would be a good exercise for all of you to work on once this demo is over. We also have a part 5, which is the quick monitoring tools, quick start monitoring tools. If you remember in the demo, I did not choose to select logging features, but if you had to select that, it would then go ahead and install Prometheus. It would use Elk, which is Elasticsearch, Logstash, and Kibana, which would show you good monitoring stats on what's happening in your private networks, all the messages passing back and forth, the blocks being created, the health of the nodes, all of that information is also available. So this guide, as you walk through it, it shows you a snapshot of each of those screens. So here's Prometheus. So again, the when you type in list.sh and run that shell script, it's going to give you all the links, and clicking on those links will bring you to each of these pages. So Prometheus here is being displayed, and it shows us some information, and it allows us to get into the metrics. And further down, I believe we do have a picture for Grafana. Okay, so that also has, yeah. So here's a picture for Grafana, and in this graph, it shows you the health of the nodes, the stats, what's running in these nodes. If you remember, all of these nodes are running as Docker containers. So if you have Docker installed, let's see if that pulls it up. So I'll just try it, getting up Docker. So yeah, so each of these nodes that we are running, the 3 member nodes, the validator nodes, the Tessera nodes, the Grafana, Prometheus, all of these are running in their own Docker containers. And these Docker containers, information from these containers are now provided to us uh, in these slides here, in these graphs. Okay, and as I was saying, you run the list.sh file, and that's going to give you a list of all the endpoints. These were the few endpoints that we've seen, and the rest of them also are displayed here. Grafana is here, Kibana is here, and we can go to their individual links, and that's what you'll be seeing on them. Okay, so, yep. They are really angry. Who's they? The demo gods. Anyways, so as we go down this quick start, we do see the next step was the smart contract, which I was talking about earlier, to send public and private transactions. I'll just go over in theory on what happens in a private transaction. So we did talk about three banks coming together, Bank A, B, and C, which translates as member A, member B, and member C in our demo. And these three members are part of the consortium, part of the private network. Member A can send a transaction to the whole network, which would then be a public transaction, or it could send a private transaction to just one of the members. When it does this, although the transaction is broadcast to all the members, only the members who are part of this transaction would be able to read the payload. In other words, the Tessera node, which I mentioned earlier, is responsible for encryption and decryption. And if the transaction is meant for a particular node, for a particular member, then its corresponding Tessera node will be able to decrypt the payload of the transaction and thus make it available to the member. All the other members in the network will not be able to read this information. So sending private transactions is a main feature of the private network. Member A sends a private transaction to member B, and then only member A and B can decrypt and see the contents of this payload, whereas member C or the other members of the network will not receive any information back from the call because they are not able to decrypt the information as the message wasn't directed to them. So that's how you use private transactions in this demo. So the demo. Yeah, I think the demo gods have signed up for the evening and have left me high and dry. So we'll just proceed with the web page and the theory behind it. So even though you have private transactions, one point to keep in mind is this network using Hyperledger Besu is capable of interacting even with the public network. So it's not necessary that you use Quorum just for creating a private network. You can also create a node and use that node to interact with the public network. That is also one of the major use cases. So if you're having an idea of using Quorum for either a public network or a private network, then Hyperledger Besu would be the flavor that you would choose. But if you're planning on just creating your own consortium with your own private network, number of nodes in it, then Go Quorum would be one of the choices that you would choose. So with these additional tools, logging and all that, this tool proves to be a very effective way for you to get quickly started with your network. For production purposes, you could of course go with the QBS or the Quorum blockchain service, which I spoke about earlier, which is hosted on Azure. So that is a managed service there. So for production networks, one smart option would be to go to a cloud provider and have your own blockchain as a service out there. Or if you are testing it out to see how to get into this area, then the quick start example, what's displayed on this page, would be the best way and the easiest way for you to get through. So with that, I'm resigning to the demo gods. It doesn't look like it's happening, and I'll hand it over back to Jason.
All right, thank you very much, Mario. That was an excellent boot camp. Actually, I learned a lot from it. I think it's going to be extremely useful. Thank you so much for saving, okay, a lot of time, okay, probably months, okay, to learn this stuff. Okay, if you were to do it alone, you basically showed how to set up a network, a private network, getting the endpoints, getting a unique chain ID. You demonstrated, okay, how transactions, okay, are done. You deploy. You wanted to deploy a simple smart contract, deploy a dApp, okay, but then you showed us where to get it. Thank you. My first question, okay, for you is, what are some of the exercises, okay, that you recommend those beginners after they have done this to take next?
Good question. So The way this guide was proceeding was it has this smart contract to deploy, and then it has this DApp to deploy. And as you would have seen, the code in here is very simple: get and set values, right? So what I would encourage developers to do is to first come up with a use case in their minds as to saying, okay, if I am bank, what would I do? Well, I have these private transactions. I need to send some information to one of these other banks in there. So come up with a use case where you have a little more involved smart contract, a little more complicated contract. Come up with this smart contract and write your front end, which is a nice little app showing the three banks and how you log in as one bank using MetaMask and send the information to the other bank, and then switch over to the other bank and see how that information comes through. Switch over to a bank who is not involved in the private transaction and see what that shows up. It should definitely show up nothing because the transaction is private and the information inside is encrypted. So write this small, do this small exercise where you have these three banks interacting with each other, and not just running it through the terminal, but in fact running it through a dApp. This would be a good way for you to showcase how well you have understood Go Quorum, how well you have understood private networks and private transactions. Put it up in your GitHub, send us a link. We would be great. We would be very glad to see that link. It would also do you a great deal in your job search because it shows prospective employers that you are familiar with a product to create a private network and how you go about doing it. So that would be the next natural progression for developers wanting to move forward in this.
Got it. Very cool. So develop a use case, demonstrate it to your peers, right? And but what if after all that, okay, that is done, and they want to take it to the next level? Where can they get? Is there a certification course, okay, or something that they can do? Uh, where do they go?
Yes, good question. So what I would do is going back to my presentation. Where is that? Right. So we do have academy courses with Consensys, so that's one great place for you to get in there and see what are the certification courses. Go Quorum also has certification courses. So the best the best way forward is to go to consensys.net, go to products, come down to Consensys Quorum, and there would be a lot of information there specifying how you would move further, how you would get certifications. Also, make sure that you are able to get to our Discord, follow our newsletters, follow the Quorum newsletters to understand what's latest in coming out in Quorum. For example, just 2 days back, I came to know that Quorum was now available as a Quorum blockchain service on Azure. So follow this newsletter and you would get to know more information. You could also chat with us on Discord, chat.consensys.net. That will take you to a Discord channel. From there, you could get more pointed questions. But to answer your question, Jason, yes, we do have certifications. We do have full-fledged courses on many of our products on our Consensys website. There is a special place called Academy where you're able to log in, register for these courses, do these certifications, and thus improve your personal skills and resume.
Okay, so we have so got it. Sign up, okay, for the newsletters, the consensus newsletters, the quorum newsletter, join the Discord, and also check out the academy. We have three more technical questions, and then we have to close the session. Before that, okay, so the first question is, how does pruning reduce storage requirements of the network?
A good question that is. So pruning is going to be uh, well, well, I would be doing a I would be doing a disservice if I answer this question right here. So it is a more pointed question, and I would be happy to send this to the product team. So as I was saying, send your message or your question on the chat, and we shall be able to handle that more in clarity and give you a correct answer.
Okay. Will Ganache be supporting Bezu and Quorum in the future?
A good question. Right now, when I was working with Truffle and Ganache, it just uses a get, but we definitely have plans for including Bezu or Go Quorum into it. It's an upcoming plan. It's on our roadmap.
Last question. How does Bezu and Quorum manage the data privacy? Will the data and the smart contract be stored on the nodes in the network or only between the participating parties?
Yeah, so the data is actually sent to all the nodes, but they would always be sent out in decrypted format. As I was talking about earlier, Tessera is our open source product which we use for managing private transactions, and Tessera is responsible for encrypting and decrypting the payload. If I had a chance to show the code, you would then see how we make these calls to make the private transaction. You have to provide the from address, the to address, and this information is used by Tessera to know whether this transaction is for this member or not. And based on that, it's able to use the private keys to encrypt and decrypt the information. So although the transaction is sent across to all the nodes, only the nodes which are part of the transaction would be able to decrypt the information and see it. As part of the demo, I would have also shown how a private transaction sent from member A to member C is done, and then all the three members query the smart contract to get the information. Member A and member C alone see the information, but member B doesn't see it, and it ends up having zero or a default value. So that would have been a clear demonstration on how the encryption and decryption is done only for the members as who are part of the transaction. You can also create member groups where a number of members are added to a group, and then you use that group ID as part of the transaction such that only the members who are part of that group will now be able to encrypt and decrypt the information.
Okay, one more question. Okay,
Yes.
question for layman. How does a layman differentiate between Bezu and Quorum?
Nice question. So, as part of the initial slide where I showed you, Bezu was developed at Consensys. It was written in Java, and it was for as an Ethereum client for the public network. Whereas Go Quorum is a fork from Get, so it is written in Golang, and it is more for a private network. So, as a layperson, you would see that Bezu is a product that supports both the public and the private network, whereas Go Quorum in Golang is written only for the private network. So those are initial ways that a layperson can differentiate between these two, and based on their use case, decide which flavor of Go Quorum that they want to go with.
Okay, so with that, our time is up. I'd like to thank Mario so much from tuning in all the way from the US in a really early hour to be with us to give this excellent boot camp, which I'm sure it's well worth watching back and then follow us step by step and saves you a lot of time. Mario, thank you. It's really a pleasure hosting you.
Thank you, Jason. It was a pleasure being here, and thanks everybody for tuning in for this presentation.
All right, okay. So that brings an end, to day number 4 of Blockchain Developer Week. Do tune in, before that, we have a brand new NFT for you. Do remember to claim your proof of attendance token by going to the Discord. The secret code that you need to DM the bot is EPO23. I repeat, EPO. It is a very how do I say, popular Malaysian tourist destination. Okay, we have a lot of good food. IPOH23. So you DM the secret code to the bot, and you can claim a really cool cyberpunk NFT for this blockchain developer week. And be back tomorrow, as we continue Blockchain Developer Week with Chain at 5 p.m. tomorrow. So it's been a pleasure, everyone. Good night, good evening. See you tomorrow. Bye.